Good evening, everyone. In the last session, we discussed about what is callable interface. Callable interface is also used to create a thread in the Java. This is a callable interface introduced in Java 1.5 version. Right. What is the difference between runnable interface and a callable interface? Runnable is a functional interface which contains a run method. Callable interface is also a functional interface which contains call method. Runnable interface is having run method. Callable interface is having call method. Runnable method returns void. That means there is no return type for the runnable. Callable interface returns object, right? Runnable interface present in java.lang package, whereas callable interface present in java.util.concurrent package. So concurrency in the multi-threading. Concurrency in the multi-threading. Perfect. Now, when we create the thread by using callable object, can we start that by using thread? Can we call that by using thread class start method? No, we cannot call that by using thread class start method. When you create the thread by using callable object, we will go for executor service. Executor service introduced in Java 1.5 version. Using executor service, we can implement multi-threading. Using executors, we can create a thread pool. Using executor service, we can submit tasks to pool of threads. So in the last session, we created thread by using callable. So my class is implementing callable interface and I'm overriding call method. So once I'm overriding the call method by using callable, here I'm using executor service, executors.new fixed thread pool. I created 10 threads by using executor service and I submitted 10 tasks to the pool. So 15 tasks I have submitted to the pool. 15 tasks I have submitted to the pool. When I submit the 15 tasks to the 10 threads, so the executor service will submit all these tasks to the pool of threads. Executor service will submit all the tasks to pool of threads. Pool of threads. Got it? Are you guys able to practice callable interface with executor service? Are you guys able to practice? Are you guys able to practice callable service? Callable interface with executor service? Are you guys able to practice callable interface with executor service? Yes, perfect. Good. Now, so there is a small concept in the thread which is called daemon thread. There is a small concept in the Java which is called daemon thread. The thread which runs in the background, is called as a daemon thread. So total we have three types of threads. We have three types of threads in Java. One is default thread created by JVM. Default thread created by JVM, that is main thread. JVM will create one default thread to run our program. That default thread is called as a main thread. Default thread created by JVM, it is called main thread. And the second one is user defined thread. Second one is user defined thread. You can create that by using thread class, or you can create that by using runnable interface, or you can create that by using callable interface. Thread class, runnable interface, and callable interface. And the third one is daemon thread. Third one is a daemon thread. So total there are three types of threads available. First one is default thread, which is created by JVM. The default thread which created by the JVM is called as main thread. Then what is user defined thread? As part of our project requirement, we can create our own thread. The thread that which we are creating based on the requirement is called as user defined thread. Okay, thread class will be available, runnable interface will be available, and callable interface will be available. Then what is daemon thread? The thread which is running in the background. The thread which is having low priority and runs in the background is called as daemon thread. The thread which runs in the background, the thread which runs in the background is called as daemon thread. Any thread which runs in the background is called as a daemon thread. Example, garbage collector. Example, garbage collector is one of the example. Garbage collector is a daemon thread. Okay, we are creating several objects in our program. That means we are allocating memory. We are creating objects in our program. We are allocating memory. We are allocating memory. Are you guys able to follow this? Are you guys able to follow this? We are creating several objects in the JVM. When we create the objects in the JVM, memory will be allocated. Then who is deallocating the memory? Who is deallocating the memory? Who is deallocating the memory in the JVM? Okay, guys. The memory deallocation will be done by garbage collector. Who is starting that garbage collector? That garbage collector will be started by JVM, right? Internally. So garbage collector will be started by JVM. Garbage collector is used to deallocate the memory. Garbage collector is used to deallocate the memory. Garbage collector is a daemon thread. Okay, how to make our thread as a daemon thread? For example, here I'm implementing runnable interface. I'm implementing runnable interface. When you implement runnable interface, you need to override run method. You need to override run method. Let me write system.out.println run method called. Run method called. Let's go for our main method. Inside the main method, we are going to create the object for a demo. Demo D is equal to new demo. Then thread T1 is equal to new thread. Thread T1 is equal to new thread of D. T1 dot start. I'm starting the thread. So I'm creating a class. I'm creating a class. That class is implementing runnable interface, and I'm overriding run method. And here I'm having main method. Demo D is equal to new demo. Then thread T1 is equal to new thread of demo. Then T1 dot start. Now see here, it is printing. The run method is executed. The run method is executed. Clear, guys? Run method got called. Run method got called. Now here, before starting this thread, I can set it as set daemon true. So set daemon true, that means it is a background thread. I'm making that thread as a daemon thread. So the daemon threads nothing but low priority threads. The threads which are running in the background, they are called as daemon thread. How to execute this? Now see here, I'm going to get thread.current thread. Thread.current thread. If current thread dot is a daemon, then only print this. Daemon thread called. Daemon thread executed. Daemon thread executed. Okay. Now here, if I don't set this line, if I'm just creating the thread object, here I have a condition. If a current thread is a daemon thread, then only execute this logic. If a current thread is a daemon thread, then only execute this logic. Else, I'm going to set like this. So system.out.println normal thread executed. System.out.println normal thread executed. Run this program. So which thread is executed, guys? Now when you go for this application, which thread is executed? Which thread is executed? So demo object I created. Demo object I pass it to thread T1 dot start. When I call the start method, internally it will call the run method. So inside the run method, it is getting the current thread object. It is getting the current thread object. If a current thread is a daemon, then execute this statement. If it is not a daemon thread, then execute this statement. Current thread is a normal thread, so it is saying that normal thread executed. It is saying that normal thread executed. If I set like this, T1 dot set daemon to true, I'm making this thread as a daemon thread. Then execute this program. execute this program. Now, when I run this program, what will happen? It is going to set a daemon thread, set a daemon true, set a daemon true. When I'm going to execute that program, what happened? So I'm going to run this program, current thread d1 is equal to new thread, set a daemon. If it is a daemon thread, then it has to print daemon thread executed. If a current thread is a daemon, it has to print the output as daemon thread got executed. It has to print the output as daemon thread got executed. Thread dot current thread is a daemon. If thread dot current thread is a daemon, it has to print the output as a daemon thread got executed. Now I want to make the thread as a daemon thread. T1 dot set daemon to true, T1 dot start. Yes, it is implementing runnable interface. It is implementing runnable interface. Run this program, right click, run as Java application. Yes, can you see the output? Daemon thread executed. If I don't set it as a daemon, then it will print the output as normal thread got executed. If I set the thread daemon as a true, then it is executing daemon thread executed. That means the thread becoming a daemon. If I don't set the thread as a daemon, it is executing like a normal thread. It is printing. So here, if I don't set this, if I don't set a daemon, it is executing like normal thread executed. Okay, if I set it as a daemon, if I set a daemon to true, then it is going to execute as a daemon thread. So what is a daemon thread? The thread which runs in the background is called as daemon thread. Garbage collector. We are creating objects in the JVM. Object creation means memory allocation. Object creation means memory allocation. So when the memory got allocated, after that object got used, after the program execution got completed, JVM should deallocate the memory. If JVM want to deallocate the memory, JVM will use a concept called garbage collector. Garbage collector is a daemon thread which is used to clean up the memory which is allocated by the JVM. What is a daemon thread? We have three types of threads in Java. One is the default thread which is created by JVM, that is called as main thread. And the second one is user defined threads. We can create user defined threads by using thread class, or by implementing runnable interface, or by implementing callable interface. And the third one is daemon threads. The thread which runs in the background is called as a daemon thread. Garbage collector is a daemon thread. We can make our thread as a daemon by using set daemon method. We can make our thread as a daemon thread. We can make our thread as a daemon thread using set daemon method. Using set daemon method. Now let us check this program. In this program, I'm creating one thread. I'm making the thread as a daemon. Then I'm calling the start method. So it is going to make my thread as a daemon thread. So this is a Java program to make the thread as a daemon thread. Daemon threads will execute in the background. Java program to make a thread as daemon. Daemon means low priority thread. Daemon means low priority thread. Got it, guys? If you don't set here, if you want to make it as false, you no need to make it as false. The default, by default, it is not a daemon thread. Whenever you create the thread, by default, it is false only. You no need to make it as false. Set daemon method is always taking Boolean value. Set daemon method is expecting Boolean value. So if you pass true, that thread will become daemon thread. If you want to set false, no need to set it. By default, it is not a daemon. By default, it is not daemon. Got it? So how to make the thread as a daemon? By using set daemon method. Set daemon, that means that thread will become a daemon thread. Daemon threads means background threads. JVM will not respect daemon threads, guys. When you make your thread as a JVM, JVM is not going to respect. If your method execution got completed, here my method execution got completed. JVM will not check whether daemon thread is running or not running. It will terminate the program. It will terminate the program. If your thread is a normal thread, JVM will wait for thread to complete its execution. Then JVM will get shut down. Then JVM will get shut down. If you go for daemon threads, JVM will not give the respect to the daemon threads. Even though if your program is running, it is running by daemon thread, JVM will stop the execution. JVM is going to stop the execution. If you want to make any low priority thread, right? Then you can make the thread as a daemon thread. Daemon thread is nothing but low priority thread. Daemon threads will be running in the background. When JVM founds daemon thread, when JVM founds daemon thread running, when JVM founds daemon thread running, it terminates the thread. It terminates that thread. It terminates the thread and then shut down the program. And then it will shut down the program. And then it will shut down that program. And it will shut down the program. When JVM reaches end of the main method, when JVM reaches end of main method, when JVM reaches end of main method, it will terminate our program. It will terminate our program. If JVM founds a daemon thread running, it terminates that daemon thread. It terminates that daemon thread and then it will shut down the program. That means JVM does not care about daemon threads are running or not. JVM will not care about daemon threads running status. JVM will not care about daemon threads running status to stop the program execution. If a normal thread is executing, then JVM will wait for normal thread to complete the execution. Then only JVM will stop the program. Right? If a daemon thread is executing, JVM will not care about normal daemon threads. JVM will care about the normal threads. If normal threads are executing, if JVM reaches to end of the method, then JVM will not bother about them. JVM will shut down the program. If a normal thread is running, JVM will take care of them. If a normal thread execution got completed, then only our JVM will shut down. If JVM reaches to end of the main method, so it has to stop the program. When it reaches to end of the main method, it has to stop the program. When it reaches to end of the main method, some daemon threads are running in the JVM. JVM will stop the daemon threads. JVM will shut down the program. JVM will not respect daemon threads because daemon threads are low priority threads in the JVM. Daemon threads are nothing but background threads. Those are low priority threads in the JVM. Are you guys able to understand what is a daemon thread? The daemon thread nothing but the thread which runs in the background is called as a daemon thread. Daemon threads also called as low priority threads. Daemon threads also called as low priority threads. The thread which runs in the background is called as a daemon thread. Thread also called as low priority thread. Garbage collector is a daemon thread. We can make our thread as a daemon thread using setDaemon method. When JVM reaches end of main method, it will terminate our program. If JVM finds daemon thread running, it terminates that daemon thread and it will shut down the program. JVM will not care about the daemon thread's running status to stop the program execution. Daemon threads are nothing but low priority threads. Daemon threads are nothing but low priority threads. Those threads runs in the background process. In real time, sir, where we are going to use the daemon threads? To be frank, I never created daemon thread in my projects. So there is a topic. Daemon thread means it is a background thread which we are going to use for garbage collection activity. That's it. In the real world, we don't create our threads as a daemon threads. I have never created a daemon thread in the project. I don't have a use case also to tell you when to use a daemon thread in our project. But concept is there, we are discussing. Are you guys clear? So what is the example for a daemon thread? If anybody asks you, have you ever created daemon thread in the project? No, we don't create that. We don't create that. I never created that. So if they ask you, do we have any daemon threads in the Java? Yes. Do we have any daemon threads in the Java? Garbage collector is a daemon thread. What is the duty of the garbage collector? Garbage collector is used to clean up the unused memory in the JVM. Garbage collector is used to clean up unused memory in the JVM. Are we running the garbage collector or it is running internally? Guys, are we running the garbage collector or it is running internally? Are we running the garbage collector or it is running internally? It runs internally. That is a background process. So can we call that garbage collector as a daemon thread? Can we call garbage collector as a daemon thread? Yes or no? Yes, we can call garbage collector as a daemon thread. We can call garbage collector as a daemon thread. Perfect. Perfect. Now let's talk about the another important topic in the multi-threading, which is synchronization. Synchronization. Already we discussed this topic in the string classes. String buffer is synchronized. String builder is not synchronized. Do you remember when we discussed about string buffer, string builder? String is immutable. We discussed about these concepts, right? String is one class in the Java. String class is immutable class. Okay. Then we discussed about string buffer. String buffer class is mutable class and synchronized class. Mutable class and synchronized class. And we discussed about string builder. So string builder is also mutable class and not synchronized class. Not a synchronized class. String is an immutable class, which is immutable. That means we cannot modify the content of the string once it is created. That's why it is called as immutable class. Then what is the string buffer? Mutable class and it is synchronized class. What is the string builder? Mutable class, not synchronized class. What is the meaning of synchronized class, not synchronized class? Synchronized class means thread safe. Synchronized class, nothing but synchronized means thread safe. Synchronized means what? Synchronized means thread safe. Not synchronized means not thread safe. Not synchronized means not thread safe. Are you able to understand what is the meaning of synchronization and not synchronization? Synchronized class, it is nothing but thread safe class. It is nothing but thread safe class. String builder, it is mutable class, not synchronized class. That means not thread safe class. Not thread safe class. String is a immutable class. String buffer, mutable class and synchronized. That means it is a thread safe. String builder, mutable class and not synchronized class, it is not thread safe. What is the meaning of synchronization? Synchronization means thread safe. Not synchronized means not thread safe. Simple example. Assume that I brought one sweet packet or sweet box. Assume that I brought one sweet box to our classroom. Offline people, listen. If I brought one sweet box to online people, though, they can't take the sweets, right? They are virtually connected. Offline people can take the sweets. Yes or no? Assume that I brought one sweet packet, sweet box I brought. In this sweet box, there are some sweets available. Okay, so there are some sweets available in the sweet box. Now, in the offline, we have 50 people. In the offline, we have 50 people. You want biryani, yeah? Rajesh is asking to bring biryani. Just opposite our institute, there is a hotel, man. You go and you can take the biryani. Go there and tell my name. Okay? Then they will ask you to pay the bill. pay the bill and they will give the biryani. All right. Okay. So here, assume that guys, assume that I have taken a sweet box packet. Assume that in this packet, there are, assume that in this sweet box packet, there are 5 sweets available or 4 sweets available in the sweet box. There are 4 sweets available in the box packet. Okay. Now here in our class, assume that there are several students available. 3 plus 2, 5, 5 plus 3. There are 8 people available. But how many sweets are there in the box? How many sweets are there in the box? Only 4 sweets are available. Now, if I keep a sweet packet on my table, if I call the people, hey, today is my birthday, I brought a sweet packet, so please take the sweets. When I announce, please take the sweets, what will happen? So people will come in the queue one by one to take the sweets, or all the people will come at a time to take the sweets. If I announce in the class, on my table, sweet box is available, please go and take the sweets. If I tell our students will come in the queue, all students will come at a time. All students will come at a time. Why? All students will come at a time. Why? If they come one by one, sweets might complete. They don't know how many sweets are there in the box. I told that there is a sweet box available on my table. Today is my birthday. Please take the sweets. If I announce that, all the people will come at a time to my table to take the sweets. If all people come at a time to take the sweets, how many sweets are available? 4 sweets are available. Then people will start fighting. I need this sweet, I need that sweet. People will start fighting. Why people will start fighting? There are only 4 sweets available, but there are 8 people available. There are only 4 sweets available. There are 8 people available. Still assume that I brought 8 sweets. So I know that there are 8 people available in the classroom. I brought 8 sweets in the box. There are 8 sweets in the box. I kept 8 sweets in the sweet box. I kept that sweet box on my table and I told 2 people, hey guys, today is my birthday. Please take the sweets. I announced in the class. All the 8 people came at a time. Then they started taking the sweets. Can you guarantee one person will take only 1 sweet? Is there any guarantee? Is there any guarantee? One person will take only 1 sweet? There is no guarantee. Now here we need to consider this sweet box as a resource. This sweet box is a resource. I counted that there are 8 students available in the classroom. For the 8 students, I have taken 8 sweets in the shop. They have given a box to me and I kept the box on the table. I announced that, hey students, today is my birthday. Please take the sweets. Sweets box is there. Sweet box is there on my table. Please take it. All the 8 people came at a time. First 3 people has taken 2 sweets. First 2 people about they came very fast and they have taken 2 sweets. If first 2 people taken 2 sweets, what happened? 4 sweets completed. 6 people are there. 6 people having only 4 sweets. This is called as data inconsistency. If one person take 1 sweet, then there is no problem. But there is no guarantee that one person will take only 1 sweet. First person has taken 3 sweets. Second person has taken 4 sweets. Completed. Only 2 people has taken all the 8 sweets. The remaining 6 people don't have any sweet in the box to take. So this is called data inconsistency problem. Now why this data inconsistency problem is coming? Last 3 people don't have any sweet in the box because only these first 5 people has taken all the 8 sweets. First 5 people has taken all the 8 sweets available in the box. Last 3 people don't have any sweet in the box. That means all students are not getting the sweets equally. This is called data inconsistency. Why there is a data inconsistency? First person taking 2 sweets, second person has taken 2 sweets, third person has taken 2 sweets, fourth person has taken 2 sweets. Completed. 8 sweets completed by 4 people. Remaining 4 people don't have any sweet in the box. Actually, when I am coming to the class, I planned that there are 8 people available. 8 people needs 8 sweets. I purchased 8 sweets in the shop. I kept in the box. I kept a box on the table. I announced, today is my birthday. Please take the sweets from the box. All the 8 people came at a time to the box. First 2 people has taken 2 sweets. Last people don't have any sweet in the box. This problem is called as data inconsistency problem. This problem is called as data inconsistency problem. Why we are getting the data inconsistency problem? Multiple students are attacking on the same box. 8 students are attacking on the same box. Nothing but these 8 students we can consider as 8 threads. 8 students are equal to 8 threads. 8 students are equal to 8 threads. 8 students are equal to 8 threads. Sweet box. Let's consider our sweet box is equal to a resource. 8 threads are working on the same resource at a time. That is called multiple threads are working on one object at a time. 8 threads. 8 threads. This is sweet box is equal to a resource, or we can call it as a object. Sweet box is a physical entity. Sweet box is called as a resource, or sweet box is called as a object. 8 threads working on the same object. 8 threads working on same object. When multiple threads works on the same object, there is a chance of getting data inconsistency problem. When multiple threads works on same object, when multiple threads works on same object, there is a chance of getting data inconsistency problem. What is the problem, guys? When multiple threads works on the same object, there is a chance of getting data inconsistency problem. That means every object is not using the data properly. 8 sweets available in the box, 8 people attacked on the box. All the people are not getting the sweets because first student has taken 2 sweets, second student has taken 3 sweets, fourth student taken 4 sweets, this student has taken only, this student has taken 3. 3 plus 3, 2, 8 completed. 3 people completed all the 8 sweets available in the box. Remaining 5 people don't have any sweet to take in the box. That is called data inconsistency problem. Sweet box we can call as one object. 8 students we can call as 8 threads. 8 threads working on the same object. When multiple threads works on the same object, there is a chance of getting data inconsistency problem. There is a chance of getting data inconsistency problem if multiple threads works on the same object. This object is not thread safe. This sweet box is not thread safe. That's why all the people are accessing the sweet box at a time. When your object is not thread safe, then multiple threads can access your object at a time. If multiple threads access your object at a time, there is a chance of getting data inconsistency problem. Are you guys able to understand the problem here? When multiple students are taking the sweets from the box, do you understand what is the problem in that process? When multiple students are taking the sweets from the box, do you understand what is the problem in that process? Come on, guys. When multiple people are accessing the same object, then what is the problem? If multiple people access the same object, then what is the problem? When multiple people access the same box at a time, what is the problem? Data inconsistency problem. Data inconsistency problem. When multiple students access the same object at a time, there is a chance of getting data inconsistency problem. Okay, so if multiple threads are accessing at a time on the single object, that object is not thread safe. That object is not thread safe. Are you guys getting my point? If 8 people are attacking on the same box, all the people will not get the sweets equally. That is called a data inconsistency. One person may take 2 sweets. 8 people, 8 sweets. But if first person taken 2 sweets, second person take 2 sweets, third person taken 2 sweets, fourth person taken 2 sweets, then what about remaining the 4 people? They don't have any sweet in the box. This is called data inconsistency problem. Why we are getting the data inconsistency problem? Multiple threads are acting on the same object. Multiple threads accessing the same object at a time. If multiple threads access the same object at a time, that means this object is not thread safe. When the object is not thread safe, there is a chance of getting data inconsistency problem. There is a chance of getting data inconsistency problem. If I want to overcome this data inconsistency problem, then what I will do? I will keep the sweet box in my hand. I will ask the people to come in the queue. Hey guys, today is my birthday. I want to distribute the sweets. Please come in the queue. For first person, I will give 1 sweet. He will go and sit in the chair. Then second person, I will give 1 sweet. He will go and sit in the chair. If I give the sweets to the people one by one, will I get data inconsistency problem? Guys, if I give sweets to the people one by one, will I get the data inconsistency problem? If I give the sweets one by one, will I get the data inconsistency problem? No. Right. Similarly, when we are working on multi-threading, we need to understand when our resource can be accessed by multiple threads at a time, when our resource should not be accessed by multiple threads at a time. Here we told that synchronization. Synchronized means thread safe. Not synchronized means not thread safe. Synchronized means thread safe. Synchronized means thread safe. That means only one thread can access the object or resource at a time. Only one thread can access an object or can access the resource at a time. Synchronized means thread safe. Only one thread can access the object or resource at a time. Not synchronized means not thread safe. Multiple threads can access the same resource at a time. Multiple threads can access same resource or object at a time. If multiple threads access the same object at a time, there is a chance of getting data inconsistency. Are you guys clear with my point? If multiple threads access the same object at a time, then there is a chance of getting data inconsistency problem. There is a chance of getting data inconsistency problem. So synchronized means thread safe. Only one thread can access the object at a time. If I'm allowing only one thread to access at a time, first person, you take the first sweet. Hey, first person, you take the first sweet. After the first person completed, you take 1 sweet. Third person, you take 1 sweet. After third, everybody should come in the queue. If here multiple threads are accessing at a time. Here multiple threads are accessing at a time. If multiple threads access the object at a time, there is a chance of getting data inconsistency problem. That means this object is not thread safe. Multiple threads are accessing the sweet box at a time. Multiple students are accessing the sweet box at a time. If multiple students access the sweet box at a time, there is a chance of getting data inconsistency. All the students may not get the speeds properly. All the students may not get the speeds properly. Are you guys clear with my point? If multiple students are attacking on the same sweet box at a time, there is a chance of getting data inconsistency. So that means multiple threads are accessing on the same object. If multiple threads are accessing on the same object at a time, that means that object is not thread safe. Multiple threads can access the same resource at a time. That means it is not synchronized. If the object is not synchronized, multiple threads can access the same object at a time. I don't want to get that data inconsistency. My method should be executed by the threads one after other. My method should be executed by the threads one after other. Okay, if my method should be executed by the threads one after other, then I need to make my method as a thread safe method. Thread safe, not thread safe. Thread safe means only one thread can access at a time. If a first thread is executing my method, then second thread should not execute my method. If a second thread is executing my method, then third thread should not execute my method. If a third thread is executing my method, then fourth thread should not execute my method. So in the project, we need to understand the situation. When we need to execute our method by multiple threads at a time, when we should not execute our method by multiple threads at a time. If you want to execute your method by multiple threads at a time, then by default, every object is not synchronized. Multiple threads can access our object at a time. But if you have some instance variables in the class, instance variables nothing but class level, instance variables are nothing but object level variables. So now one object is having an instance variable. If multiple threads are accessing the same object, instance variables will be shared by the multiple threads. If multiple threads share the same instance variable, there is a chance of getting data inconsistency problem. Okay, guys, in my class like this, I'm having one variable, public class, some movie is available. Public class movie is available. Okay, guys. Now here I have one variable int available tickets. Available tickets is equal to, I have given some 20. Now here I have a method public void run method. Public void run method. Now what I am going to do, book ticket. One thread is going to book the ticket. After booking the ticket, what I am doing, I am incrementing that way, decrementing that variable available tickets. I'm decrementing the variable movie tickets. Assume that book my show. Book my show having a class movie booking, movie ticket booking. Okay, int available tickets is equal to 20. Initially, they started the openings with the 100. So in the theater, 100 tickets are available. So int available tickets is equal to 100. Public void run book ticket, logic to book the ticket. Logic to book the ticket. Once the ticket booking is completed, they are reducing the tickets, decrementing. So once one ticket is booked, this count will become 99. This count will become 99. When this book ticket logic will execute, if there is a operation called if available tickets greater than 0, if available tickets greater than 0, then only this logic should execute. If available tickets greater than 0, then only this logic should execute. Understand my point? So here I am having a movie ticket booking. In this I am having a run method. In that run method I have a logic. If the available tickets count is greater than 0, then I will write the logic to book the ticket. Then I am decrementing the tickets count. If it is 100 greater than 0, okay, one ticket booked, then it became 99. Then second ticket booked, it became 98. Like this, there is a logic in the run method. Now assume that in this program we created multiple threads. In this program, multiple threads are available. I'm going to create thread T1 is equal to new thread, and I'm going for thread T2 is equal to new thread. Okay, and I'm going for thread T20 is equal to new thread. I'm going to start T1, T20, start. I'm starting the threads. Now, how many threads are getting started in my program? Can you guys tell me how many threads are starting my program? In my program, how many threads are getting started? How many threads are getting started? 20 threads are started. Okay, guys, 20 threads are started. Now, 20 threads are going to execute which method? Same method or not? All the 20 threads are executing the same method or not? If all the threads execute the same method, there is a instance variable. There is a instance variable. Then first thread will consider as 100. When the first thread is executing, so second thread will take that, third thread will take that, 100th thread will take that. Is there any chance of getting data inconsistency problem here? Is there any chance of getting data inconsistency problem here? They will read the data incorrectly. First thread will read it as 100. First thread will read it as 100. Second thread will read it as 100. When the first thread is executing this line, this code, the tickets will become 99. But what second thread will do? Second thread also will read the data as 100. Third thread also will read the data as 100. Fourth thread also will read the data as 100 because first thread not completed the logic. If a first thread decrement the value, then it will become 99. First thread, second thread, 20th thread or 15th thread are waiting here to execute the logic to book the ticket. When the 15 threads are executing the logic to book the tickets, now my 16th thread started. When my 16th thread started, what is the value it is considering? 100. After 16 thread started, 15 threads completed the execution, then this value will become 85. But my 16th thread is reading as 100, but actual value is 85. So there is a chance of data inconsistency when multiple threads are working on the same method. When multiple threads are working on the same method, there is a chance of data inconsistency. Data inconsistency, nothing but reading incorrect data. Data inconsistency, nothing but reading incorrect data. Are you guys able to follow my words? What is the data inconsistency? Data inconsistency, nothing but reading incorrect data. When we will get the data inconsistency problem, if multiple threads are working on the same object, then there is a chance of getting data inconsistency problem. If multiple threads are working on the same object, then there is a chance of getting data inconsistency problem. Okay, guys, in the project, few scenarios are there where thread safety is required. Few scenarios are there where thread safety is not required. For example, if you go to our website, there is a method in the program. If you go for our website, there is a method in the program. That method is used to display online training schedule. If multiple threads access online training schedule at a time, is there any data inconsistency? If multiple people access online training schedule functionality in our website, is there any data inconsistency problem? No. So there is a method which will display online and training schedules. If multiple threads access this program at a time, there is no problem. If multiple threads access this logic, there is no problem. That means multiple people can access online training at a time. For all the people, same output will come. There is no data inconsistency. But so let's talk about movie tickets booking. Let's talk about train tickets booking. Let's talk about flight tickets booking. So when multiple people are booking the same flight ticket, there is a chance of getting data inconsistency. So you and me started at a time. I selected seat number 10. You also selected seat number 10. We both are trying to book the seat number 10 at a time. Then program should book the seat number 10 for which user? Okay, guys, you are booking the flight you are booking a flight ticket. You are booking a flight ticket from your home. I am booking a flight ticket from my home. We both want to go for Bangalore from Hyderabad. From Hyderabad, I want to go for Bangalore. I selected a flight. I have selected a ticket. Or bus tickets, seat number. Whenever you go for bus ticket, they will ask you to select the seat. I selected the seat number 10. You also selected seat number 10. We both are trying to book the same ticket at a time. That means you are one thread, I am one thread. Okay, so if multiple threads are trying to access the same object at a time, there is a chance of getting data inconsistency problem. So to avoid this data inconsistency problem, there is a concept called synchronization. There is a concept called synchronization. Synchronization means we will allow only one thread to access our resource at a time. If 10 students, if 8 students attack on the sweet box at a time, there is a chance of data inconsistency. If these 8 students attack on the sweet box at a time, there is a data inconsistency. If I ask the people to come in the queue, then I will tell, hey, I will give the first person, take the sweet. Hey, second person, take the sweet. Hey, third person, take the sweet. If I give the sweet to person one by one, then data inconsistency will not come. If all the people come at a time to the sweet box, if they attack, then there is a data inconsistency. Similarly, when we are executing our program, if multiple threads access our object at a time, then there is a problem of data inconsistency. Sir, how to avoid this data inconsistency? When one thread is booking a movie ticket, another thread should not access the method. When first thread is accessing the method, second thread should not access the method. If a first thread completed the execution, then only second thread should execute the method. When the second thread execution is completed, then only third thread should execute the method. Once the third thread execution is completed, then only fourth thread should execute the method. So that is called thread safety. Thread safety, not thread safety. Thread safe, not thread safe. What is the meaning of thread safe? Thread safe means only one thread can access this object at a time. Only one thread can access this object at a time. If your object can be accessed by only one thread at a time, then that is called as a synchronized object, or we can call it as a thread safe object. When we have the object as a thread safe object, we don't get any data inconsistency problems. Okay guys, my first thread is booking a ticket. So first thread booked the ticket, then ticket count became 99. Then only my second thread will come. Second thread will book the ticket, then count will become 98. Then third thread will come, then the value is 98. So my threads will execute the program one by one, one by one. That is called thread safety. That is called synchronized. So in the project, there are some scenarios when we need to go for synchronization, when we should not go for synchronization. Okay guys, so in the project we have the concept of synchronization concept. So when we need to go for synchronization, synchronized means only one thread can access the object at a time. Not synchronized means multiple threads access the same object at a time. If a multiple threads access the same object at a time, then there is a chance of getting data inconsistency problem. Okay guys, so to avoid data inconsistency problem, we need to use synchronization concept. What is that guys? We need to use synchronization concept. To avoid data inconsistency problem, we need to use synchronization concept. So synchronization means allowing only one thread to execute the logic at a time. Synchronization means allowing only one thread to execute our resource or object or logic at a time. Okay guys, right? Synchronization means only one thread can access the object at a time. Not synchronized means multiple threads can access the same object at a time. So in the above program, multiple threads are trying to book the ticket at a time. There is a chance of getting data inconsistency. Okay, in the above program, multiple threads are trying to book the tickets at a time. Multiple threads are trying to book the tickets at a time. If a multiple threads access the same object at a time, then there is a chance of getting data inconsistency problem. To avoid data inconsistency problem, we need to use synchronization concept. Synchronization, excuse me guys. To avoid data inconsistency problem, we need to use synchronization concept. Synchronization means allowing only one thread to execute our logic at a time. Okay. Come on, guys. So do you understand what is a thread safe? What is not thread safe? Are you able to get the clarity on what is a thread safe? What is not thread safe? Guys, come on. Are you able to understand the concept? What is a thread safe and what is not thread safe? What is the difference between thread safe and not thread safe? Can anyone tell me? Can anyone tell me the difference between what is a thread safe and what is not thread safe? Can anyone tell me what is the difference between thread safe and not thread safe? If the object is accessing by multiple threads at a time, that means it is not thread safe. If only one thread can access our object at a time, that means it is thread safe. So which one is recommended? Thread safe is recommended, not thread safe is recommended. Guys, tell me, thread safe is recommended or not thread safe is recommended? Thread safe is recommended or not thread safe is recommended? Which one is recommended in the project? Which one is recommended in the project? Thread safe is recommended. Not thread safe is recommended. It depends on the project requirement, guys. Don't come to conclusion. Don't come to conclusion. It depends on the project requirement. Depends on the project. Now, if I make a online training schedule display as a thread safe, then what will happen? Can multiple people access my online training schedule at a time? Or I should allow the people to access one by one. First person accessing from US online training, the rest of the people should wait to access online training schedule in the Ashoka ITR. When the first person is checking the online training schedule page, remaining people should wait to see the online trainings in the Ashoka ITR. Come on, guys. The remaining people should wait to see the online training schedule in our website. When one person is accessing our website, remaining people should wait for that. Remaining people should wait for that, or all the people should be able to access at a time. All the people should be able to access at a time. All the people should be able to access at a time. So depends upon the project scenario, we will go for either thread safe or not thread safe logic. In the Java, string is a immutable class. We already know that. String buffer is a mutable class. Synchronized. String buffer is a synchronized. What is the meaning of string buffer is a synchronized? What is the meaning of string buffer is a synchronized? It is a thread safe. What is the meaning of thread safe? Only one thread can access a string buffer object at a time. Only one thread object will access thread safe object. Only one thread can access string buffer object at a time. When one thread is accessing string buffer, other threads cannot access the string buffer because string buffer is a synchronized. Only one thread will access. Once the first thread execution is completed, then only second thread can access the string buffer. It is a thread safe. When you go for string builder is a mutable class and not synchronized. That means it is not thread safe class. Multiple threads can access a string builder at a time. Synchronized means thread safe. Only one thread can access at a time. Not synchronized means not thread safe. Multiple threads can access the same object at a time. Multiple threads can access the same object at a time. Are you guys clear? Are you guys clear with my point? Very good. Now, so here, if multiple threads access the same object at a time, then there is a chance of getting data inconsistency problem. To avoid the data inconsistency problem, we need to use the synchronization concept. Synchronization means allowing only one thread to execute our object at a time. Allowing only one thread to execute our logic at a time. By using synchronization, we can achieve thread safety. That means only one thread can access our logic at a time. Data inconsistency problems will not be available. By using synchronization, we can achieve thread safety, but it will slow down our execution process. 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 Are you able to follow this? Are you able to follow this? Now, here, if 10 people access at a time, there is a data inconsistency problem. Suppose, for example, I kept a box like this. I kept a object like this. Now, T1 is available, T2 is available, T3 is available. There are 3 threads. T1 available, T2 available, and T3 available. Okay, T1, T2, T3. If I make this object as a synchronized object, can these 3 threads access at a time? No, they cannot access at a time. So multiple threads cannot access the synchronized object at a time. Okay, after first thread completed, then only second thread can access. After second thread completed, then only third thread can access. So if you make your object as a synchronized object, when first thread is accessing, second thread and third thread cannot access. Second thread and third thread cannot access. This is sync object. Sync object nothing but thread safe object. Only one thread can access at a time. After first thread is completed, then second thread. After second thread completed, then only third thread. One by one, they will execute. So if you go for synchronization, you can achieve thread safety, but execution process will become slow. One by one. Are you able to understand? What is a synchronization? What is synchronization? Synchronization is the process of implementing thread safety in our logic. Okay, synchronization means achieving thread safety. When you don't want multiple threads to execute your logics at a time, then we need to go for synchronization. Okay guys, when you don't want to go for multiple threads to execute your logic at a time, then we need to go for synchronization. If you want multiple threads to access your logic at a time, then no need of any synchronization. Multiple threads can execute at a time. So if you have multiple threads, then you need to think about the data. Are they sharing any data? If there is any data sharing happening, then you will get a data inconsistency. If there is no data sharing, then there is no problem. Got it? Now, how to achieve synchronization? We can achieve synchronization in 2 ways. One is synchronized method, another one is synchronized block. How to achieve synchronization? Using synchronized method, using synchronized block. If you want to achieve thread safe, then you need to go for synchronization. What is the meaning of synchronization? I will write one method. That method should be executed by only one thread at a time. If I want to achieve that synchronization, either I can go for synchronized method or I can go for synchronized block. Okay guys, so what is the syntax? For synchronized method or for synchronized block? If you want to, there is a method called public void m1. Inside the m1 method, I have some logic, and I have some other logic. Okay, so here important logic is available. Okay, pre logic available and post logic available in my method. important business logic available here. Pre-logic available, post-logic available, important business logic available. Now, this important business logic should be executed by only one thread at a time. Then this important logic I will keep in the synchronized block. Okay, this important business logic I will keep in the synchronized block. This important business logic I will keep in the synchronized block. Synchronized block. Are you guys clear with my point? Synchronized block. Okay, which object? That object, whatever the object that is executing, that object will pass here. Important business logic I will keep in the synchronized block. Syntax for synchronized block. Syntax for synchronized block. Are you guys getting my point? How to achieve synchronization? We can achieve synchronization using synchronized keyword. Synchronized keyword we can use at the method level or at the block level. So my method is having some business logic. My method is having business logic. That logic, some important logic is available in the method. That important logic should be executed by only one thread at a time. That important logic should be executed by only one thread at a time. Only this important logic should be executed by only one thread at a time. This logic can be executed by multiple threads at a time. But after this logic is completed, when first thread is executing this logic, second thread should wait. When second thread is executing this logic, third thread should wait. After third thread completed, then only remaining threads. One by one only can execute this logic. This is syntax for synchronized block. When to go for that synchronized block? The whole logic is not important. Only important business logic should be executed by only one thread at a time. Then we will go for synchronized block concept. Synchronized block concept. For example, I have a method called yum2. I have a method called yum2. Syntax for synchronized method. Okay, in this method, some important business logic is available. In this method, important business logic is available. When first thread is executing the M1 method, second thread should not execute it. For that, I will go for synchronized method. If I make my method as a synchronized method, only one thread can execute my method. If I start two threads, when first thread is executing M1, second thread should wait. When the second thread is executing M1, third thread should wait. When the third thread is executing M1, fourth thread should wait. When the fourth thread is executing, fifth thread should wait. You can secure your complete method as a synchronized method by using synchronized method. Okay, when you go for synchronized method, only one thread will access this method at a time. If you go for synchronized block, my whole method no need to be synchronized. It will decrease my performance. It will decrease my performance. Okay, guys, it will decrease my performance. Are you guys clear with my point? Are you guys clear with my point? It will decrease my performance. It will decrease my performance. So here, what we need to do, if your method total logic is important, then go for synchronized method, no problem. If total logic is important, then go for synchronized method. Total logic is not important, only this business logic is important, then keep a synchronized block. If your whole logic is need to be thread safety, if you want thread safety for the complete logic in the entire method, then go for synchronized method. The total logic is not synchronized required for synchronization. Only few lines of code is required for the synchronization. Then go for synchronized block. So synchronization means achieving thread safety. If you use a synchronized keyword, using synchronized keyword, we can achieve synchronization. Using synchronized keyword, we can implement synchronization. Synchronized keyword we can use at two places. Synchronized keyword we can use at two places. Okay, one is synchronized method and another one is method level, at a block level. at method level, at block level. How to achieve synchronization? Using synchronized keyword, we can achieve synchronization, or we can implement synchronization. How many places we can use that synchronized keyword? We can use a synchronized keyword. We can use synchronized keyword at the method level, and we can use a synchronized keyword at the block level. Syntax for synchronized block. So only few important lines we are keeping in the block. This is synchronized block. Okay, so my method is having some logic, pre-logic available, post-logic available, important logic available. Only these few lines of code is important for me. Then I will go for a block. If my whole method is important, then I can go for method level synchronization. If a whole method logic is not important, then only these few lines of code is important. Then we can go for block level. So are you guys able to understand what is a synchronization? Whenever we have the multiple threads can work on the same object at a time. If a multiple threads works on the same object at a time, if a multiple threads works on the same object at a time, there is a chance of getting data inconsistency. If you want thread safety, then you need to go for synchronization. If you want thread safety, you can go for synchronization. Synchronization means allowing only one thread to access our object at a time. Synchronization means allowing only one thread to access our logic at a time. Only one thread to access our thread at a time. Okay guys, so what is the advantage if we go for only one thread to access at a time? Thread safety will be available. Data inconsistency problems will not come. When one thread is accessing my method, another thread cannot access my method. Only one thread can access my method at a time. So how to achieve that synchronization? To achieve the synchronization, we are going to use synchronized keyword. To achieve synchronization, we are going for synchronized keyword. How many places we can use the synchronized keyword? We can use the synchronized keyword by using method, and we can use the keyword at the block. We can use the synchronization at the method level, or we can use synchronization at the block level. Are you guys able to understand? Are you guys able to understand how to achieve the synchronization? We can use the synchronization at the method level. We can use the synchronization at the block level also. We can use the synchronization at the method level, and we can use the synchronization at the block level also. Are you guys clear with my point? Are you guys clear with my point? Come on guys. Okay, let us see the example. Let us see the example for that. Now here, for integer I is equal to 1, comma, I less than or equal to 10, comma, I plus plus. Okay, I is equal to 1, I less than or equal to 10, then I plus plus. Are you guys clear with my point? Are you guys clear with my point? Or else let me write this public void print numbers. Public void print numbers. Okay, so this is the method which is going to print the numbers. This is the method which is going to print the numbers. System.out.println of I. After printing the each number, I want to hold my thread for some time. 1 second. I want to hold my thread for 1 second after printing the number. thread dot sleep. Thread dot sleep. Okay, guys. Are you able to understand my method? This method is called print numbers method. This method is responsible to print the numbers from 1 to 10. After printing each number, it will sleep for 1 second. Wait for 1 second. Wait for 1 second. 1000 milliseconds I have given. It will wait for 1 second. Inside the run method, I'm just calling print numbers method. Inside the run method, I'm calling print numbers method. Now, demo d is equal to new demo. Thread t1 is equal to new thread. Thread t1 is equal to new thread. Then I'm going to call t1.start. I'm going to call t1.start. Okay, run this program. See the output, guys. Demo program I'm executing. Thread demo d, sorry, make it as a thread. Then I'm going to call this program. I'm going to execute. Right click, run as Java application. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so are you able to understand how these numbers are printing now? When I run this program, are you able to understand how the numbers are printing? 1. After printing each number, it is waiting for 1 second. For 1 second, it is waiting, then it is continuing its execution. How many threads are accessing print numbers method? How many threads are accessing print numbers method? Come on, guys. How many threads are accessing print numbers method? Only one thread. Can I access that thread name? Thread dot get thread dot current thread dot get name. Thread dot current thread. Thread dot current thread. Okay. I'm going to print the thread name, which is printing the number. Now let's run the program. Run as Java application. Now let us see. How many threads are created now? One user-defined thread is created. That user-defined thread printing the numbers. Thread 0 printing 1 to 10. How it is printing 1 to 10? After each number printing, it is waiting for 1 second and it is printing. Thread 0 printing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, it is very simple and straightforward logic. I have a method called print numbers method. In that method, I have a logic to print the number. After printing the number, it is waiting for 1 second. Then it is continuing the execution. How many threads are accessing? Only one thread is accessing. Now let's go for second thread. Thread T2 is equal to new thread. Then T2.start. T2.start. Now let's run the program. Guys, can you see what is happening? Can you see what is happening? Both threads are executing or not? First thread 1 is executed, 2. Thread 1 executed, printed 1. Thread 0 printed 1. Thread 1 printed 1 0. Thread 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 1 0. Why? Because whenever I called T1.start, first thread came here, first thread printed the value, then first thread in the sleep mode. When the first thread is in the sleep mode, second thread also came, second thread also printed 1. Then second thread went into the sleep mode. By the time second thread went in the sleep, first thread completed the sleep, it restarted the loop execution, printed 2. First thread printing 1, going to the sleep, then second thread printing the 1. First thread printing 2, going for the sleep, then second thread coming and printing the 2. First thread printing 3, then going to sleep, second thread coming and printing 3. Are you able to understand how the values are printed? Now, print numbers method is executed by multiple threads at a time or only one thread accessing at a time? Guys, tell me here, print numbers method is executing by one thread at a time or print numbers method is executed by multiple threads at a time? Come on. Come on, guys. Print thread method is executing by multiple threads at a time or print thread is executing by one thread or print thread is executing by multiple threads at a time? Print numbers method is executing by one thread at a time. Print numbers executing by multiple threads at a time. Multiple threads. You see the output. First thread printing 1, second thread printing 1. First thread printing 2, second thread printing 2. First thread printing 3, second thread printing. That means this method is executing by multiple threads at a time. But my requirement is when first thread is printing the numbers, second thread should not go to the method. When first thread is printing the numbers, second thread should not go to the method. How can I make this method is a synchronized method? This method is a thread safe method. This method is not a thread safe method now. Guys, print numbers method is a thread safe method or print numbers method is not a thread safe method? Print numbers method is a thread safe method or it is not a thread safe method? Print numbers is not a thread safe method. The reason multiple threads are accessing at a time. Print numbers method is not thread safe. That's why multiple threads are accessing the method at a time. Can we make this method as a synchronized method? Guys, can I make this method as a synchronized method? Come on. Can I take this method as a synchronized method? Yes. What is the meaning of making synchronized method? What is the meaning of synchronization? What is the meaning of synchronization? What is the meaning of synchronization, guys? What is the meaning of synchronization? What is the meaning of synchronization? Can you tell me? What is the meaning of synchronization? Allowing only one thread to execute our logic at a time. Why we need to make our method as a synchronized method? Why we need to make our method as a synchronized method? Come on, guys. Why we need to make our method as a synchronized method? Thread safe. Thread safe. When first method is executing my method, second thread should not execute that method. Okay. How can I achieve synchronization now? Currently, I am having a thread class demo. In the demo class, I have a print numbers method. Print numbers method I am calling inside the run method. I'm calling t1.start, t2.start. Two threads started at a time. When the t1 is started, it is calling the run method. It is calling the print numbers method. When the t2 is started, it is calling the run method. It is calling the print numbers method. First thread is executing print numbers. Second thread is also executing print numbers. When first thread entered into the loop, it is printing I value. After printing I value, it is going in the sleep. When the first thread is in the sleep time, second thread also coming here, executing the loop printing I value. By the time second thread printing I value, second thread also going to the sleep mode. By the time second thread is in the sleep mode, first thread completed the sleep time, it printed 2. After printing 2, it is going to sleep. Then second thread coming and printing I value. Second thread also going sleep. Then first thread completed the sleep time, printing I value as 3, going to sleep. Every thread printing the value, going to the sleep. After that, continuing the execution. So that's why when I run this program, we are getting the output as thread 0, thread 1, thread 0, thread 1, thread 0, thread 1, thread 0, thread 1, thread 1. Now see here, thread 0, thread 1, thread 0, thread 1, we are getting the output. Are you guys see here? 1 1 printed by both threads, 2 2 printed by both threads, 3 3 printed by both threads, 4 4 printed by both threads, 5 5 printed by both threads, 6 6 printed by both threads, 7 7 printed by both threads, 8 printed by both threads, 9 printed, 10 printed. But order is guaranteed. Here 9 printed by first thread and 0th thread. But 10 printed by 0th thread first thread printed next. The order is not guaranteed, but execution is guaranteed. Who is taking care of this execution of the threads? Thread scheduler. So 2 threads are working on the same method at a time. 2 threads are executing the same method at a time. Now I want only one thread to execute my method at a time. How can I tell to JVM to execute my method by one thread at a time? By using synchronization. So thread safe. I want to make my method as a thread safe method. What is the meaning of making thread safe method? I will use a keyword called synchronized keyword. Public synchronized void print numbers. My method is a synchronized method. Now let's see here. First 0th thread is executing. When the 0th thread is executing, first thread is executing or first thread is not executing? Now first thread is started. Can you see the output? Can you see the output? Earlier, when I don't keep synchronized, when I keep synchronized, can you see the difference? When I don't keep synchronized and when I keep the synchronized, can you see the difference? Come on, guys. When I don't keep the synchronized and when I keep the synchronized, can you see the difference? Are you able to understand the difference? When I keep the method as a synchronized method, what is the output we are printing? First, 10 numbers printed by thread 0. After first thread completed the execution, then only second thread printed. Then only second thread printed. If I remove the synchronized keyword, if I remove that synchronized keyword and if I execute this, see, both threads printing 1, both threads printing 2, both threads printing 3, both threads printing the method, executing the method at a time. 2 threads are executing the method at a time. That means my method is not thread safe. If I want only one thread to execute my method, then I will go for synchronized. Then I will go for synchronized keyword. Then run this. Run this. See, thread 0 is executing. When thread 0 is executing, thread 1 is not allowed. Thread 1 is not allowed. My method is a synchronized method. Thread 0 completed. After thread 0 completed, then only I'm going for thread 1. Then only it is going for thread 1. Are you able to see synchronization practically? Guys, are you able to see synchronization practically? Yes or no? Tell me, what is a synchronization? What is the benefit of synchronization? What is synchronization and what is the benefit of synchronization? What is synchronization? What is synchronization? Thread safety. Synchronization is nothing but thread safety. You can use this synchronizer for any method, whether it is a runnable or callable, that doesn't matter. Synchronizer keyword you can use for any method. If your method is synchronized, only one thread is going to execute that method at a time. Here we have a advantage, we have a disadvantage. What is the advantage and what is the disadvantage, guys? When you go for this concept, what is the advantage and what is the disadvantage here? What is the advantage and what is the disadvantage? What is the advantage and what is the disadvantage? Advantage is thread safety. Disadvantage is slow in the execution. Disadvantage is slow in the execution. Okay, good. So are you able to understand what is a synchronization? Synchronized means thread safe. Not synchronized means not thread safe. By default, every user defined method is not thread safe. Okay, multiple threads can access the same resource at a time. If multiple threads access the same object at a time, then there is a chance of getting data inconsistency problem. To avoid data inconsistency problem, we need to use synchronization concept. Synchronization means allowing only one thread to execute our resource at a time. By using synchronization, we can achieve thread safety, but it will slow down our execution process. How to achieve synchronization? Using synchronized keyword, we can implement synchronization. Okay, synchronized keyword we can use at two places. Synchronized keyword we can use at two places. One is at the method level, second one is at the block level. Syntax for the block level. Now you see, instead of writing the complete method as a synchronized method, I can write only this loop logic in the synchronized block. Synchronized this. Okay, this complete logic I can keep in the synchronized block. This is also fine. This is also fine. Only setup logic we can keep in the block. Only setup logic we can keep in the block. Now thread 0 is executed, then only thread 1 is started, because that logic is a synchronized block logic. You can use a synchronized keyword at the method level, or you can use a synchronized keyword at the block level also. You can use at the method level, you can use at the block level also. Anything is fine. Sir, when to go for method level, when to go for block level? If your complete method should be accessed by only one thread at a time, then you will go for method level. Then you will go for method level. In that method, there is some logic available. Only some piece of lines of code is important to be executed by only one thread at a time. Then you can go for block. Then you can go for block. So here, synchronization, method syntax, synchronization, block syntax. Okay, Java program with Java program with a synchronized method. Java program with a synchronized method. In the above program, we are starting two threads. We are starting two threads. Two threads will access print numbers method to print the numbers from 1 to 10. If a print numbers method having synchronized keyword, then two threads will execute the method sequentially, one after other. If we remove synchronized keyword, from the print numbers method, then two threads will access that method at a time. We can see the difference in the output. Okay, so here, if I keep synchronized keyword for the method, when I print that thread 0 is printing the numbers from 1 to 10. Once the thread 0 is completed, then only thread 1 will start. 10 numbers completed. Then see, thread 1 started. First thread, second thread. First thread and second thread. Okay. If I remove sleep also, no problem. Yeah. So there should be something here. Yeah. Let me remove this completely. Now see, first 0th thread is printing, then only first thread is printing. Even that sleep is not mandatory. My method is a synchronized method. So first 0th thread will print the numbers, then only first thread will print the numbers. See here. Now, see now what happened? Order is changed. First thread executed, thread 1 executed first, then thread 0 is executed. Can we guarantee order of the thread's execution? Earlier 0th thread executed first. Now first thread executed first. But when the first thread is printing the numbers, this 0th thread is not printing the numbers. So here we can set the names for the threads. T1 dot set name. I can say my thread 1. I can say this is thread 1. Now here I can say T2 dot set name. Here I will say that thread 2. Thread 1 and thread 2. Two threads are started. Two threads are calling run method. Inside the run method we are calling print numbers method. Print numbers method is a synchronized method. Now see the order. Which thread executed first? Second thread executed first. Second thread printed the numbers from 1 to 10. Then first thread printed the numbers from 1 to 10. First thread printed the numbers from 1 to 10. Thread 1, thread 2. But can you guarantee the order every time? No. Who will take care of that order? Now see, thread 1 executed first. Then thread 2 executed. Who will control the thread's execution order? Programmer or thread scheduler? Programmer or thread scheduler? Thread scheduler. Thread scheduler. Okay. If you want to sleep your thread for some time, if you want your thread to be slept for some time, okay guys, thread dot sleep of 1000 milliseconds. Okay, e dot print stack trace. Good. Now we can see the output clearly. Thread 1 is executing first. Thread 1 is executing first. Thread 1 is printing the numbers from 1 to 10. Once thread 1 printed the numbers, then only thread 2 is printing the numbers. Why only one thread is executing completely? Because it is synchronized. If I remove the synchronized keyword, if I run this program, thread 1, 2 executing parallelly. Can you see the output? Understand the difference with the synchronized, without synchronized? Guys, can you see the difference with the synchronized and without synchronized? Come on. Synchronized, thread safe, only one thread can access at a time. Synchronized means thread safe, only one thread can access at a time. So if I remove synchronized keyword, both threads are executing at a time, both threads are printing the numbers parallelly. But if I go for synchronized, only one thread is executing. Synchronized is a keyword. That keyword can be used at the method level. That keyword can be used at the block level. That keyword can be used at the method level, and that keyword can be used at the block level. Perfect. With this we understood what is synchronization. With this we understood what is synchronization. Next, we need to understand what is deadlock and what is inter-thread communication. We need to understand what is a deadlock and what is inter-thread communication, and we need to understand what is join method, what is a join method, what is yield method. Okay, if we discuss these 4 topics, then our multi-threading will be completed. Come on guys. So what are the remaining topics available in the multi-threading now? Deadlock is available, inter-thread communication is available, join method is available, yield method is also available. If we complete these 4 topics, then we are done. Wait method is coming under this inter-thread communication. Wait method, notify all. We have seen in the object class there are some methods available. Na? What are the methods available? Wait method available, notify method available, notify all methods are available. Wait, notify all. These methods are available. By using these methods, we can achieve inter-thread communication. Deadlock available, inter-thread communication available, join method, yield method, fork method. Okay, fork method, but we don't use them in the real time. Just for sake of syllabus, I'm going to explain. Okay, guys. Fork and join, inter-thread communication, deadlock, yield methods. Yes, these 4 topics I will explain in the tomorrow session. Then we are done with the multi-threading. Okay, guys, tomorrow also we have only online class, so I'm unable to come to institute for offline. So tomorrow also our class will be available only in the online. From day after tomorrow, I will come for the offline. From Friday, I will come to institute, then we will take the offline class. For tomorrow also only online is available. So today you guys are having Oracle class also. From today, Oracle classes are resuming. So trainer was not well from last 2 to 3 days. So the classes will continue of the Oracle from today. Today at 9 o'clock, you guys are having the Oracle session. Got it? So tomorrow also we have the class in the online, guys. Offline people, you can attend the class in the online for only tomorrow. So tomorrow we will complete our discussion related to multi-threading. Okay, please practice this daemon thread and synchronization. Today we discussed about a daemon thread and we discussed about synchronization. Daemon thread nothing but the thread which is running in the background is called as a daemon thread. Garbage collector is one of the daemon thread in the Java which will run in the background to clean up unused memories. Then we discussed about synchronization. Synchronization means thread safety. Thread safety means only one thread can access the object at a time. Not synchronized means multiple threads can access the objects at a time. How to achieve synchronization? By using synchronized keyword, we can achieve synchronization. Synchronized keyword we can use at 2 places. One is at the method level, another one is at the block level. Okay, when you use synchronized keyword at the method, even if you start 10 threads also, only one thread can access at a time. When the first thread is executing this method, second thread cannot execute. Once the first thread completes the execution, then only second thread will access. Once the second thread execution is completed, then only third thread can access because my method is a synchronized method. Synchronization means thread safety, allowing only one thread to execute the resource at a time. Synchronized keyword we can use at the method level, we can use at the block level. So which one is more recommended? Depends upon the situation. If your whole method logic need to be executed by only one thread, go for method level synchronization. In this method, 20 lines of code is available. Only 5 lines are very crucial. Only 5 lines should be executed by only one thread at a time. Then you can go for synchronized block. Depends upon the requirement. Okay, guys. Now, so tomorrow we are going to talk about the remaining pending topics. That is, one is the deadlock, another one is inter-thread communication, join and fork methods in the multi-threading, another one is yield methods. So these topics we are covering for syllabus sake and for interview purpose, but we don't use them in the project. Okay, so by tomorrow we'll complete our discussion related to multi-threading. Thank you, guys. We'll continue tomorrow. Tomorrow class is also only online. Thank you.